Uh, so this is module 9 of the electronics course. We're going to talk about series parallel resistors today, and we may save the demo until next week. Um, so we're going to talk about resistors in series, resistors in parallel, um, Ohm's law, and the use of resistors, and then a demo. Well, I'll just show a quick demo, but we'll do the analysis of the circuit next week. So resistors come in different values. Typically, they're color coded and have at least 3, if not 4, bands on it, which tells you the value plus the tolerance. They also come in different sizes, from 1/8 of a watt all the way up to like 10 watts, and there's even like 100 watts and 250-watt resistors. They can be made of carbon material or wire wound material. Wire wound is a problem for RF. Uh, it acts more like an antenna and can also add inductance to the circuit. And you may not want to add inductance to the circuit. So carbon material is better. So when we look at resistors, you can either have them in series, which means that they're sort of connected back to back. So, R1 is connected to R2, which is connected to R3, and then it loops back to a power source. If the resistors are connected in parallel, they're sort of connected this way, where each side is connected to the power source. So R1 is connected, R2 is connected, and R3 is connected. Now, if you have resistors in series, to get the total value, you just add R1 plus R2 plus R3 together, and you get the total value. Um, Now, resistors in parallel, you have to use this formula, which basically is 1 over R1 plus 1 over R2 plus 1 over R3. You add all these together, and then you take the reciprocal of this to get the R total. Now, if you only have 2 resistors in parallel, you can use this formula, R1 times R2 divided by R1 plus R2. Or even easier is if you have all of the values the same, you just divide by the numbers. So, if you have two 10-ohm resistors here and you have 2 resistors, you divide it by 2, and that'll give you 5 ohms. And if you happen to have 3 resistors of 10 ohms, you divide it by 3, which gives you 3.3. So you don't always have to go through this formula here. This is just a summary. Series resistors, just add them together. Here you have to take the reciprocal, unless they're of the same value, and then you just divide by the number. Now, looking at Ohm's law, basically you have a resistance, a current flowing in the circuit, and voltage. So you measure the voltage across the resistor, and you have a battery or a power source. So, E equals I times R, voltage equals current times resistance. So if I measure the current and I know the resistance, I can determine the voltage here. Now, Ohm's law is basically just, you have a power source, a voltage, you have them pushing electrons through, and you have a resistance. And this is the resistance, which is, like a tube, you're squeezing a tube together. So when we look at resistors in series, and we measure, for example, the voltage. Let's say so we have a 1 kilo ohm resistance, a 2 kilo ohm resistance, and a 6 kilo ohm resistance. So the total resistance here is going to be 1 plus 2 plus 6, which is 9. And you have 1 milliamp of current going through here. So if you measure the voltage across the first resistor, it's 1 kilo ohm times 1 milliamp, which gives you 1 volt. If you measure it across the second resistor, you get 2 volts. And if you do it across the third resistor, you get 6 volts. And when you measure across all of them, you get 9 volts. So when you look at this, V1 equals I times R1, V2 equals I times R2, Vn equals I times Rn. So here in a series circuit, the current is constant. So it doesn't matter if I measure the current here, measure the current here, or over here at B. And we'll do that in the lab demo next week. Now, when the resistors are in parallel, it's just the opposite. Because the voltage is running along here, the voltage is the same across each resistor, but then the current is now different. So the current here is now V divided by R1, I2 is V divided by R2, and IN is V divided by Rn. So now if you measure the current out here, it's I1 plus I2 plus IN. So its voltage is the same. You have to add the current together. And use of resistors, you can use them as a dummy load for your antenna. You can use them as a voltage divider, or you can use it as a power attenuator. Here's just examples of some dummy loads. Basically, it's a big 50 ohm high power resistor, either made up of one big resistor or made up of small individual ones to take the load. So you could have like 10 500 ohm resistors, and then you could multiply the power by 10 to take the load. When you Yeah, this is basically what I'm saying is, the power level goes up with the resistors. So if you put 10 500 ohm resistors or 470 ohms together, or you could, for example, put 1K resistors together as a dummy load. A voltage divider is basically a way of dividing the voltage. So so it's a ratio between R1 and R2. And so the V out is V1, which is your starting voltage divided, typically the ratio of R2 divided by R1 plus R2. And this is how you can make a voltage divider to reduce power. But it gets a little bit more complicated with a load, because this load now is in parallel with this resistor. So the calculations become a little bit more complicated. Now, an attenuator is typically used to reduce power, RF power, in your radio, or, for example, a signal coming into your receiver. And there are T attenuators, which looks like this with 3 resistors, or you can have a pi attenuator, which looks like this. And there are different designs and calculators out there to calculate different values. So if you want to drop your signal by 3 dB or 10 dB, and you want a 50 ohm impedance, for example, for your antenna, it'll tell you what values of resistors to use. And this is the antenna is typically using dB. We haven't talked about impedance or dB yet, so that'll be coming up in later sections. So that's basically it for the Ohm's law, and I'll just do a quick demo and we'll get into the demo in more detail, and then we'll go on to the wilderness protocol. So let me just pull up the other camera here. So all of you should be seeing this circuit. Now, one of the things is we're going to be doing this with light bulbs today, but we'll be doing it with resistors tomorrow, next week. I mean, one of the things is that oftentimes you don't actually see what's going on in your circuit. And so, you have to have some intuition and some feel about it. So so basically, we've got a battery here. We've got a switch here connected to two lamps in series and two lamps in parallel. And instead of using these jumpers here, I've just used some wires to connect everything together. So if we so if we look at, let's say, one light bulb and we turn that on, you can see the intensity of that light bulb. Now, if we connect two together, you'll see that the intensity remains the same. If we're going to measure the current in this circuit, you begin to realize that the resistance value must go down, and the two lights remain the same. Now, if we look at the circuit in series, um, we look at one light bulb, it's bright. If we hook two together, it goes down. So the resistance must be going up in value because the lights aren't as bright as anymore. So if we compare the two, you can see for parallel they're the same, and for series they go down in brightness. So we'll be analyzing this circuit next week with resistors and actually measuring the voltages and the currents. So, any questions on Ohm's law? All right, let me just stop share and turn off the recording.